A few weeks ago, I suggested a random voting system that uses a tombola as part of its mechanism could be more effective than first past the post. I made a couple of assumptions, but today we are going to test those assumptions using programming in Golang. This is Storyfeet. I am Matt Stoodley, and you are watching a video. I've managed to download some election data. It was surprisingly hard to find. You feel like that kind of thing ought to be really public, but I managed to get some, and it is the worst formatted file I've ever seen for anything like this. Here's the it's comma separated data, so at least I can handle that. But check out the order. I mean, the parties are mixed in with the various other things, like election year, swing, followed by Labour, which is a party, SNP, MMP, and then constituency name just randomly thrown in. And then, of course, you've got to pull all of this out. So that took a little bit of work to get the information out, but nothing too ridiculous. So I've got real election data. We are going to see how Tombola compares to first past the post. We can't compare AV in this because people have to vote differently for AV. But with Tombola, the votes would look, well, they wouldn't look exactly the same, but they would look near enough like this that we can run the tests and see the results. So let's do that. Let's open it up. So if I just open up, okay, so basically the important detail here is we have a constituency type. Once we've loaded all of the stuff, we have this constituency type, which is basically the name of the constituency plus the votes, which is a map of string party name to int number of votes. That's the basic type of any constituency. And then the rest, I've got a couple of functions for reading the file, obviously. And then this get balls tells you how many balls each party gets under the Tombola voting system. Basically by saying, depending on how many balls there are supposed to be, if there are supposed to be 100 balls, we times the number of votes by the number of balls, divided by the total number of votes. And then we give each party that appropriate number of balls. If that number of balls would be less than the minimum number of balls for them to be in, so you need maybe 3% or 5% of the vote to actually get any balls in the Tombola, which is just a thing to try and stop too small parties from getting too much sway in places where they shouldn't. So just put a small minimum on that. But primarily the focus is to try and keep the result as proportional as possible, so we can see how each of these does. Next, the next function, select ball. Once we've got the number of balls each voter gets, this uses the Tombola system to choose one ball just using a fairly basic throw it in an array and pull a random element from the array. And I also have a function for first past the post winner as well. And that just takes the number of votes in a constituency and returns a winner and the number of votes they got. There's nothing particularly fancy there. The main function basically just loads the file, and then it creates these three different things. We want to get the result of first past the post. We want to get a proportional result. This is the proportional result, and this is the Tombola result. These two should probably be the other way up, actually. Let's have the proportional result first, because in some ways, the closer to proportional the result comes in, the better in many ways. But we don't really want to lose constituency representation, which is the big problem with proportional representation. I kind of want to be able to have a constituent MP that I can go and talk to and moan at. And you lose that with proportional representation direct, but you keep that with Tombola and first past the post. So let's run the program and I'll show you what we get. So if we go run star.go, first we end up with, where are we? So the proportional representation, the Conservatives got 276 seats, Labour got 260. Now this is quite different to what you see when you see under first past the post, where the Conservatives got 317 and Labour 261. Now, I think these numbers are off by one because some of the data's a bit weird, but still, principally, Conservatives beat Labour by a teensy amount here, proportionally. But the number of seats difference is massive. That's crazy. That bothers me immensely about first past the post. However, if you look under the proportional representation result, Conservatives still win, and Labour comes second. But it's much closer to what it ought to be. I mean, if you again compare, Lib Dems got 48 here, and here they got 37, so not a million miles off. Whereas under first past the post, Lib Dems got 12. SNP here got 20 seats under proportional. Here they get 35, which is quite. Remember that under first past the post, they got significantly more seats than they earned proportionally. And actually, they're much closer to that under Tombola. So that's the result that Tombola voting gets. Quick rundown on Tombola voting for those of you who are wondering. Basically, every party gets a number of votes. The votes are turned into a number of balls in a Tombola for each constituency, and at each constituency you pull out one ball from the Tombola, and the winner of that Tombola basically gets the seat in Parliament. It's a lot of random, but spread over 650 seats. The random is kind of balanced out, and you end up with a relatively steady. If I run this program again, we will get slightly different results because it's just using random, which is seeded by the time now. So, again, Conservatives 280, Labour 268, but the numbers are still fairly close to what they were last time. So there's kind of an expectation. Now, of course, that's a different set of Conservative MPs each time, which is why you really want to have this deterministic. But there's a couple of other things that I'm concerned about and I would like to fix. One is that I think order needs to be preserved. I think the party with the most votes should get the most seats. No, I think we've been lucky in the last two examples that has basically happened. Yeah, I don't think it should be possible for any party with fewer votes to have more seats. And so my theory on this is that we use a deterministic random seed that can be that can be calculated by anyone who has the numbers, who has the basic file, and then we run until we have a legitimate ordering system. But first, I want to just show, I do want a quick comparison on the Tombola system, and I'm going to run the Tombola vote 100 times and compare which one, and take its worst proportional score and see how that stands against first past the post. Okay, so here's how I want to score the proportionality. Basically, I'm going to take away 1 point for every vote, for every step away from proportional representation that party has. So in this case, the Conservatives should have got 276 seats. They got 317, so that would be approximately 50 points there, right? 51 points off of what it should be. And then for Labour again, that's only 1 point off, so that's kind of fine. They would get the 1 point. And then for Lib Dem goes 48 to 12, so that's a difference of like 36. So we'll just add that up and see how proportional each of these systems are. In fact, let's so we need a function that basically takes two sets of results, which is a map of string to int, right? And returns how proportional they are. So I'm going to go to proportion.go because that feels like the place to put this. And we'll make a func and we'll call it compare. And this is going to take A and B, which are both map of string to int, and it is going to return an int, which is its score. I think a low score is good, so we'll just put that. In Obviously the difference, it doesn't matter which way that difference goes, so when we actually compare this, we need to make sure. Now there's a couple of things. First I'm going to run through A, so for k comma v colon equals range A, we then need to find in B its partner, don't we? So p comma ok colon equals and k is the key, so b at k if not ok p equals 0. Yeah, and so we have a value for a and a p. Why do we call this AV and we call this BV? So A value and B value, right? Now we need a score equals 0 if AV minus BV is greater than 0. Score plus equals AV minus BV. I'm going to put this in an else. Score plus equals BV minus AV. And so our score would then... Now there is of course one small problem with this. Return score. We actually need to go through B and see if it's got anything that's not in A. So we're going to do that as well. Compare. So I need to run through B for k comma BV colon equals range B. And here we are looking specifically for the ones that don't exist. Okay, so if underscore comma OK does no, yeah, if underscore comma OK colon equals A at K semicolon not OK. So if we didn't find one here, then score plus equals BV. And basically what I'm doing here is I'm checking that, I'm assuming that if that's not okay, then that result would be 0 anyway, so I don't need to do any careful addition there. And that enables me to get the results from that. And I used K, I've used BV, so that shouldn't complain. So now we have the compare function. Why not do some comparisons here? So funct.println score, and then we will include was in proportional, yeah. Compare of seats is the FPTP winner, so we'll just do PR to seats. And here we're going to do a funct.println score and compare of PR again, but this time to TOMB, which is our Tombola score result. And now when I run this, we should get, oh, not even a single complaint. So notice, first past the post got a score of 125. That's 125 seats that are wrong. Tombola, on the other hand, got a score of 71 seats. Now, if we run this many times, we will get different scores. That's 59. That's much closer. 59 again. Now, a small note that's worth saying here: we've deliberately included in the get balls, in the call to the get balls function, there's a function called Tombola here, and this calls get balls with 3. If we make that work with 0 and we run this, the score actually still comes fairly close, does it? Sometimes it can go down as low as 29. Now we can run this many times and we can see what the worst score is. In fact, let's do that. Let's see what the worst result we can get is with let's go back to a limit of 3, because I still feel like that's a helpful thing to have for this. Now this is, if you don't get 3 balls, you don't get any balls, basically. So we'll put that back up to 3. And then what we're going to do instead at main.go proportion was in main.go, wasn't it? We have our key function which calls here. Now I'm going to put this in a loop. Okay, I'm just putting a first one here. Now for I equals 0, so we're going to I is less than 100, I plus plus, and in here what I'm going to do is I'm going to run that 100 times. Now this is something we could actually do and aim for the most proportional result. If we agree functionally that we will seek, we will run this like 10 times and seek the most proportional result, we can do that and make this a more legitimate voting system. So we will run this 10 times and choose the one which scores the best in the proportional score. So S score 2 colon equals, oh no, we need to do another T2 colon equals Tombola constits, and SC2 colon equals compare PR to T2. Now if SC2 is less than B score, then Tomb equals T2, B score equals SC2. Okay, and then honestly we can just use B score at this point, can't we? So C2 yeah, so now this will be the best scoring one. We run it 100 times. We can get a proportionality of 27 using that. 23. That's not bad, right? We can get a reasonably proportional government, still with major parties and small parties, and we can still keep some of the smaller parties. I guess the reason for keeping, you don't want to have too many small parties because that kind of leads to a weird fracturing system, right? But you do want to have small parties, so I feel like that's actually a pretty good result. Of course, we could do the opposite, right? Let's aim for the worst score possible, and see even if that fails against first past the post. So where's my comparison? It's here. Let's do it that way. Okay. Now we run this, and our score is still a worst score we managed to get was 109. The worst score we managed to get there was 95. 97. So the worst score we're getting, let's run it 1,000 times. And it's going to start to get a bit slower, but if we run it 1,000 times, see what the worst possible score we can get from this is. And the worst possible score with 1,000 runs, 113. That is amazing, because even with the weirdest, furthest apart one, and we can look at it, Labour got a 308, Conservatives. So yeah, Labour won that one by a mile, so they probably... Did they quite win the House there? Okay, so with the worst one, but even so, it's still as proportional as the thing. And I've not worried about order preserving. I was going to make a thing about preserving order, but actually, just by focusing on beating that, because if we do that way again, run it 1,000 times, get the same result. Oh, that was wrong. Switch this one back. So we've got to still wait 1,000 times and see what result we get. Now, with a score of 17, a reasonable level of stuff. But here's the fun part about this. Like, I mean, that's pretty close to proportional representation. And the Greens get 3 UUP, UKIP get 13 seats. Now, I don't know what your thoughts are on UKIP, but I really feel like people need to have their voice heard in Parliament, even people who we disagree with. And 13 seats for UKIP, if they're getting 13% of the vote, or 13 whatever of the vote, that's actually appropriate. You know, all these parties that people need their voices heard, and to feel their voices heard, otherwise they're just going to get more angry, right? So we do need to get... that's not bad, you know, run it 1,000 times, take the one that's closest to proportional, and you still end up with a really strong constituency-based accountability, because there's no guarantee for any individual MP that they are going to win in their constituency, which means they have to listen to their constituency just to be able to get the result that they want. Now again, I'm going to take this number back down again when I call the Tombola method. Make that 0. Now with 1,000 runs of this, can we get an even closer proportional representation? I wonder. Score of 9. That's not bad. Greens getting 9, UKIP getting 10, which is actually fairly close to their vote count. UUP, SF. That's pretty darn close, isn't it? I mean, there's a maximum of 9 votes off in the whole thing. So yeah, Greens got 11%, 11/650th of the vote. UKIP got 12 of them, and they ended up with basically the right number of seats if you take off the 0. But I'm still tempted. I'd still rather keep this at 3. Other people can disagree with me about this, right? It's just the principle that we can get a government that is relatively proportional, using the Tombola voting, the random vote, and just doing it a number of times, using a deterministic thing, and pulling that result out. Now, does this preserve order with this? So, Conservative, Labour, Lib Dem, SNP, UKIP. Conservative, Labour, Lib Dem, SNP, other UKIP. Okay, well, others. So it doesn't preserve order perfectly, but doesn't do badly. The first 4 seats, 276, 260, 276, 260, 277, 263. So a slight increase there. So there are ways of making this work, and hopefully that you will, maybe you'll agree with me, maybe you won't, but I actually think that this is quite a tidy voting system. We end up with relatively decent proportional representation. At a local level, your MP is as likely to be the MP you voted for, if not more likely, than under first past the post. You get more freedom to vote true, as I've mentioned previously. I actually think with this minor change where you just run it 1,000 times and take the most proportional based on a really simple scoring system, you can end up with a solid government elected. I mean, we could run this 10,000 times. It will take more time, won't it? Obviously, it takes a second or two, but there's no major punishment to the server if this takes a few minutes to get. Like, again, this can be tested. This can be easily verified. Whatever you do, as long as you've got your random seed and the random number generator, everyone agrees on them, you can do this wherever. And we can do that. We've got that in blockchain and stuff all over the world. Agreed upon patterns of random generation that everybody shares. Time to get rid of first past the post forever and replace it with a random ballot rolled many times. Honestly, I really don't care. I just want to get rid of first past the post. If we got AV, that would be such a step towards real government accountability. Whatever. 10,000 times we end up with a score of 15. That's because I think we had the 3, right? If we pulled that down to 0, we'd probably get something much closer to 0. It's a full-on proportional. This is quite a fun little experiment. I'll cut some of the times out on this, but it's been really good to see that this works, you know. And again, if the program is open source so that everybody can read it, everybody can see it, everybody can scrutinize it, everybody can run it on their own machines as soon as they get the vote results, you're laughing, aren't you? And every individual MP wants more votes because they want to increase their individual stuff. So they're not even going to be happy with 50% of the vote. They are going to have to please literally their whole constituency if they desperately want to stay in government. And that level of accountability really suits. And I think that's a nice thing about random, is that for each individual MP, they are motivated to please everybody in their constituency, not just that small 10% that they need or 20% that they need, and just, forget everyone else, they don't matter. You have to keep everyone in your constituency happy. That means you have to represent them, and that is what we need in government. So yeah, we go. So if you set that number lower, obviously you get more of the smaller parties and they get more seats in places. But if you set that number slightly bigger, some of the smaller parties are still lowered, but more people would be voting for them anyway because they feel free to vote true. So they might actually do better even with a 5% cut, because these votes were taken under first past the post, and under first past the post, so many people vote tactically, and under Tombola voting, or random ballot as it's otherwise called, people can vote true. And so many of the smaller parties would actually get votes on that grounds that people would support them. So hopefully you found that interesting, and you'll certainly consider doing something about first past the post. Either way, please like and subscribe to the video if you did. Oh, on that note, I've been seeing some stuff and people seem to say they need a target worth of likes and subscribes, and that helps things to get going. So guys, let's see if we can reach 1 million likes and subscribes on this video, and if we manage that, I will make another video. How's that sound, guys? This has been a video with Matthew Stoodley from Storyfeet.